Now that you've reviewed some basic stats with standard deviation and standard error of the mean, what could this look like on your AP exam? Here is a question from 2014. This would be considered a long FRQ. Pause the video here, read the prompt, but keep in mind that you're not going to be asked to graph anything on this year's exam. I will show you the graph. What you could be asked to do is look at the graph and analyze the data. So pause here, read the prompt, and then we'll take a look at the graph. A few things to point out in this prompt is number one, they're talking about these things called trichomes. Again, on the exam, they are going to give you a real biological scenario that you most likely have never seen before. We never talked about trichomes unless we did this question together in class. You are not expected to know what trichomes are. If you look at the prompt, they tell you exactly what they are. They tell you their purpose, they tell you what they are, where they're located. So don't get stuck up on the trichome and what that is. Okay, they kind of give you the background information up here. What you're asked to do then is pay attention, this is kind of tip number 2, to the words in bold. Those usually are at least 1 point. So if this was the real AP exam, you would get some points for creating a graph. Usually that's a 3-point thing. But again, on this year's exam, you're not going to see anything with creating graphs. You're going to be given the graph. Another bold word that you see is identify. That's probably a point. Justify, so giving some reasoning, giving some explanation to your answer would be a point. Describing is another point probably, or at least maybe 2, depending on what the rubric says. Another is identify, and another is predict. So as you are writing your answers on the exam, make sure you are hitting each of those words. The grammar does not have to be pretty. You don't need to have transition sentences. You do not have to have introduction sentences. Just write scientifically. Okay, so some tips there. But I digress. Now let's focus on this question. If this was on this year's exam, they would probably ignore letter A and say, okay, here's your graph. Okay, so just reviewing standard error of the mean. They give you the mean for population 1, and they asked you to graph 2 standard error of the means. Now, if you look back at the data, 1 standard error of the mean was 1. We need 2. So we would go up 9 plus 2. We would go down 9 minus 2. There is our 95% confidence. We are 95% confident that the true mean for this population is somewhere between 7 and 11. For population 2, our mean was 11. We go up to 13. We go down to 9. We're 95% confident that our true mean is somewhere between 9 and 13. And repeat for population 3. The mean is 14. We take it up to 16. We take it down to 12. We are 95% confident that the true mean lies here. Now, looking at part B, what do they want us to do with that data? Based on this data, identify the 2 populations that are most likely to have differences, and then justify. So identify and justify. I'm assuming that's going to be a 2-point part. Let's look. In order to determine if there's a statistical difference, you want to find the bars that do not overlap. Again, you can do that mathematically or you can do that visually. Let's compare population 1 and 2. The range is 7 through 11 and the range is 9 through 13. Are there any areas in there that overlap numerically? Yes, they overlap here at 9, here at 10, and here 11. So there's overlap. There's no statistical difference there. Now, what about population 2 and 3? We have a range between 9 and 13 and 12 and 16. Is there an overlap? Yes, we have one here between 12 and 13. So there's no difference between these 2 populations. Now, what about population 1 and population 3? We have 7 to 11, and then we have 12 to 16. Are there any overlaps in those numbers? No. So for part B, the first part, the identify part, you would say something like population 1 and population 3 have statistical differences. The end. That's all they're asking you to do. Don't elaborate, don't word vomit, just state what the prompt is asking. Population 1 and population 3 have statistical significance between them. The second part of that is the justify. Okay, so this is where you want to use your data, you want to use your graph, you want to use your 2 standard error of the means to justify that claim. You could say something like, population 1 has plus or minus 2 SEM, 7 to 11, right? A range of 7 to 11. Population 3 has plus or minus 2 SEM of 12 to 15. Those numbers do not overlap. The standard error bars do not overlap. Therefore, there is a statistical difference. So for this particular question, you want to use that data. You want to use the plus or minus 2 standard errors of the mean. Part D, no, I guess it would be part C, sorry. Part C is now a 3-pointer. Describe the independent and dependent variables and a control treatment for an experiment to test the hypothesis that higher trichome density in plants is selected for. So there's a lot of words there. This is going to be talking about experimental design. Design an experiment to test that higher trichome density is selected for, so is beneficial. So looking what we need to do, we have to have the independent variable, the dependent variable, and a control treatment. So there's 3 things to describe. Then they go on to say, identify an appropriate duration. So how long is your experiment going to go? And predict the experimental results that would support the hypothesis. How would you know if your experiment supported the hypothesis that higher trichome density is good? Okay, so let's take a look at the rubric. So this is part of the rubric that was taken off the College Board's website. They give you 2 possible ways to earn your points. Okay, so for your designing the experiment part, there's 3 points: your independent variable, your dependent variable, your control, your duration, how long this is going to last, and then your prediction. How would you know if your experiment supported the hypothesis? So here's 2 ways to do this. You could say that we are going to have herbivores in one group and no herbivores in another. So that's what's going to be different between your groups. And you're going to count the number of trichomes on the plants. So in your experimental group, the one with the herbivores, you would count how many trichomes there are. And the group without the herbivores, you would count how many trichomes there are. In this case, our control group would be the group of plants that does not have herbivores present. We should follow this for more than 1 generation because we are talking about natural selection, and that takes quite a while, at least 2 generations to see an effect. And then how would we know if this kind of supported our hypothesis? We would see that in the group with the herbivores, we would see increased trichome density. So we would see more trichomes on those plants compared to the plants that did not have the herbivores present. Okay, so that kind of shows that herbivores determine trichome density. The other possible way to earn the points, you could say that what we're going to do different between the groups is have the density of trichomes different. So you could start with a group of plants with minimal trichomes, a group of plants with medium amount of trichomes, and a group with higher density of trichomes, and then all of the groups get herbivores. Okay, you could count this by the reproductive success, so how many plants survive and reproduce, or just how many plants in general survive. The control group is going to be the one that has the lowest trichome density. And again, to follow this, we would have this for more than 1 generation. And our prediction, how would we know if our hypothesis was supported? The population of higher trichome density should be larger than the one that had less trichomes, right? Because the trichomes are supposed to help protect those plants in the presence of herbivores. So the population that had the trichomes, we should see them be able to survive more and reproduce more. So part C really asks you to do quite a few things. It's asking you to identify different things about an experiment and then design it, really. So as you saw in my video from last Wednesday, question number 1 on the AP exam, this is a perfect question for what it could look like. Think about what we did. Let's go back to the prompt. We asked you to look at a graph. We asked you to analyze that graph using statistics. And we asked you to do experimental design, all right? So designing an experiment to test this. So this question is a beautiful example of what question 1 could possibly look like on the AP exam, okay? Now, at the end of this section, there is another prompt. This is from the 2016 exam. I have used this on my mock exam before. This is a good spot to pause and try one. Now that we've reviewed what the standard error of the mean bars mean, this is a great video, or I'm sorry, this is a great question for you to practice. And the good news is if you have the PowerPoint in front of you, if you flip to the next slide, that gives you what the College Board was looking for. So this is a quick one. This is a very short FRQ. Take a couple minutes, practice it, check your answers, and then reach out to me if you have questions. Thanks for listening.